Thank you, everyone, and welcome to the Building AI-Driven Sustainable Network session. So I'm Inês Pacheco. I'm leading the connectivity pre-sales in Capgemini Engineering Portugal. Mayuri, do you want to present yourself?
Yeah, thanks, Inês. I'm Mayuri Tendulkar. I'm Director in Software and Digital Innovation Group. I'm based out of India.
Thank you, Mayuri. So today we are here to talk about strategies to build more sustainable networks with AI and machine learning. But first, I'm going to start by sharing a personal fact about myself. So growing up, my parents were constantly nagging me about to turn off the lights, don't let the water running and those stuff. And now, today, I found myself doing exactly the same thing with my daughter. And the other day she asked me why, and I just found a very simple question for answer actually to a 3-year-old, which is because it's good for the planet. But the truth is, I worry about her future. Climate change is here, and we are feeling more and more the impacts of climate change. The extreme events have increased more than 80% in the last 20 years. And this is really powered by the increase of temperature that we have been feeling in the last years. So we are now at the +1 degree stage. And what we have to do now, it's really to avoid to be above the 1.5 degree stage. And to do that, companies all around the world, countries all around the world, in the Paris Agreement agree to reduce the -45% of their emissions until 2030 compared to 2010 targets. But the sad truth is that all studies point that we will not even reduce, but will even increase. And this is United Nations data. So we will increase even more 10% until 2030. And the main sources, this is not new information for you, I'm sure, but the main sources that are for gas emission, it's energy. And out of the energy, we are talking about one of the biggest pieces of the pie, it's electricity and heat production that we need for everything, as you know. And the fastest way of doing this is turn off the lights. We need to reduce our energy consumption. It's not enough only to produce greener energy. We need to reduce as well. But the objective is not to stay in the dark, okay? It's to shut down the lights when and where it makes sense. And we have in our hands one of the most powerful tools. We are talking about artificial intelligence and machine learning, because it enables us to identify when it makes sense and where it makes sense to shut down resources by predicting when the resources will not be used. And unlike other hardware or CapEx investments, AI offers a really easy to deploy solution with quicker wins and actually with a good return of investment. So if we talk about, and if you focus on the telecom sector, and bear in mind that this must be done all across industries, but today we are focused here today in the telecom sector. In the last years, we have been seeing an exponential growth in terms of energy consumption for the telecom operators. And with 5G, we are even expecting this trend to continue to grow with increase of traffic, with the demand of increased throughput, more and more devices connected. And what we want with 5G is actually to invert this trend and have a more flattened curve in terms of energy consumption. And this is how the project BOSE has raised. So BOSE has an holistic data-driven approach towards energy saving for telecom operators. And what we are proposing then is to turn off the lights, but in this case, shut down unused resources across 4 different domains. Across core network, infrastructure that supports all telecom network, edge side as well, but also the radio access network. And today we will focus here on the radio access network because it's where the operators are spending the most of their energy consumption. So operators are spending 20% of their operational costs only in energy. And 70% of this is on the radio access network. So we will focus today here and present strategies of how to shut down capacities on the radio access network in order to not impact service performance, but having this energy reduction. Mayuri, are you with us?
Yeah. Are you able to see my screen?
Yes.
Yeah, thanks, Anis. Thanks for this great introduction. As I think Anis clearly said, how is really the need for energy saving? It's for overall our nature as well as telco industry. But why we think like really machine learning is helping in this energy saving? As we see 5G with 5G technology, though 5G is bringing lot of energy levers, 5G is also bringing huge data traffic and lot of data for operators to analyze. Now, this huge data, it is difficult to really analyze with just human and really derive analytical insights of it. And that's where machine learning really plays an important role. We have various types of data like weather, traffic, quality of service, and this data can really get effectively analyzed. We see here the graph where we see different traffic load and the rules or the thresholds which are applied, they are like preset or manually decided. But what AI, machine learning, offers us is really tune our logic to with that load pattern and really have these options or here these areas where we can really save energy. Plus, this also offers how we can intelligently select. There could be different energy saving features which will be coming up. Like it can have, like if we see this, we see a traffic flow pattern where we see some areas where it is long energy saving and it can have short energy saving. So all this intelligent selection of ES features is also really getting enabled by machine learning. And this also is the self-learning. So, as we say always, one size doesn't fit all. This kind of solution, it really optimizes itself. It keeps self-learning due to advanced machine learning techniques, and it really helps to optimize the energy optimization. Ines clearly mentioned about our project post. So it is our initiative, sustainability initiative under GreenNet program. And we have named it Project Post to pay the tribute for our great Indian scientist, Dr. Jagdish Chandra Bose. He was considered like a father of radio of science. So our solution features what it covers. One is vendor agnostic. This is becoming very, very important as the technology is moving towards a lot of open related platform and to work with different vendors which are bringing radio network stack. Solution having vendor agnostic is very, very critical. Second is quality of experience ensured. There is always a trade-off when we try to bring some kind of optimization features. When we are saying to save the energy, we need to turn off some of the cells, but that also should have make sure that the quality of experience for the customers is not impacted. So our solution really intelligently manages load, energy, as well as quality of service. As this is a complete data-driven solution, this has managing operational intelligence through advanced machine learning platform. This radio access network, the solution mainly focuses on radio access network and it supports traditional as well as ORAN. As ORAN is becoming the new standards and it is becoming like open platform, really bringing multi-vendor ecosystem, we need to have a solution to support brownfield as well as a greenfield deployment. And it is very flexible to support new use cases like as the spec evolves. It could be multi MIMO, it could be advanced sleep, it could be carrier switch off. So the solution is really equipped with that. This is our high level methodology of our closed loop energy saving. Why we say closed loop? And that's very important because whatever data we learn, whatever analyze, but what decision we take, it's really important for us to understand the impact of the decision and then act upon the decision based on the results. And that's why we call this as closed loop energy saving. This is a data-driven solution. So a lot of input data can be variety of cell load, user quality of experience, power, energy. Variety of data is getting ingested into the system. And based on that data, predictions are derived, like traffic, mobility, quality of service. And based on analytic insights, we take decision. The decision can be any capacity cell on off, any traffic steering related. But once this decision is applied, we also, the solution constantly monitors the feedback. It monitors any QoS impact. And if any QoS impact is seen, it may take any mitigation activity or it can take any contingency activity. So that's why this closed loop saving or closed loop approach is very, very important. This is our architecture. I'll not go into more detail, but just want to touch upon it. This is our energy saving application, which is built on Net Anticipate, which is our MLOps platform. And this is actually the operator network, how we can collect the data and we take the action. And this is our design, like how this solution is really using different flavors of MLOps. So lowermost layer, which is a telemetry and data ops, which is taking the data. Then we have complete layer of MLOps from our Net Anticipate, which takes the data, performs model training. And then using these models, the decisions are taken. And we have three flavors like simulation, open loop, closed loop. And based on that, different use cases are derived. So this is one kind of generic approach, and this can get applied and customized of two different type of use cases. And this is completely data-driven AI machine learning focused. We have been doing pilots with some of the operators, and this is from one of the pilot what we have done for one tier 1 European operator. Here we see a view of like quick snapshot of Spain cluster, and we see here the radio towers where we see some are green and some are orange, where green indicates energy saving is enabled and orange indicates energy saving is disabled. And any of this we can see how much is the energy saving we are achieving. So for this particular site, it is around 60.96. And what we have seen that with this pilot, we were able to achieve 10% over on above what currently existing solutions are there. So that way we are able to prove our solution effectiveness. And this way it is becoming one of the popular choice for the operators to really go for this AI driven RAN energy saving solution.
Thanks, Mayuri. So let's just see a short video about this solution.
Will you react to net zero targets and spiraling energy prices? Or lead what's next in smart network management? We know we need to break the ever-increasing energy curve for 5G. We also know energy consumption accounts for 23% of network OPEX, of which 73% is taken up by radio access networks. The good news is that Open RAN architecture can deliver better energy efficiency than traditional RAN. But Open RAN still consumes a significant amount of energy, even when there's little or no traffic. So, why not turn off network capabilities when they aren't needed? The problem is knowing when that is. Capgemini and Intel have developed an ORAN Alliance-compliant, AI-enabled energy-saving application that predicts network usage patterns. Which means you can switch off cells and carriers with zero impact on user experience and service. All managed and monitored by an easy-to-use dashboard and control center. The result? In our lab-grade pilot tests, we made energy savings of up to 16%. Get ahead of the energy curve. Turn on savings with AI-enabled energy reduction. Get the future you want.
Remember when I said at the beginning that we will be above of our emissions in 2030? That's because even study says is that more than 90% of the entities that committed to these targets are in risk of failing, not achieving these targets. So the time to act is now. And this is happening because we are not really committing. So we need to commit first with our net zero targets and put these at the center of our business models. We need to act, build more sustainable products, more sustainable services, operations, and infrastructures, and look at these at the end-to-end value chain of the product. And of course, monitor, because the only way to change is first for you to know where you are. Only then you can change. And for this, all of these data and AI and machine learning are key for this. So remember, and to come back at the beginning of the session, if we do the right use of the data, we can really shut down the lights without being in the dark. Thank you very much.